Myself Krishna Singh, and today I am going to discuss about the very important method for the preparation of 1 degree amine. So one method is very important for the preparation of 1 degree amine, that is the Gabriel phthalimide synthesis. And why it is very important? Because we have seen a trend in a lot of exams like the CBSE board and NEET or JEE mains or IIT advanced. We have seen a lot of the question coming from this topic each and every year. Okay, that's why we are going to discuss it broadly. So first of all, the name is Gabriel phthalimide synthesis. So what does it mean? Okay, so Gabriel was a scientist who discovered or who invented this process for the preparation of the 1 degree amine. After that, this process named Gabriel. Okay, phthalimide is the chemical reagent that is being used in this process. That's why we are writing here phthalimide. Synthesis means normally synthesis means prepare something. Okay, so we will prepare 1 degree amine in this reactions. So whole our aggregate we can say that Gabriel phthalimide synthesis. So what happens in these reactions? We are going to begin our experiment with a very simple way. So first take a chemical reagent, that is phthalic acid. So I am drawing the structure of phthalic acid. Let's see here. This is phthalic acid. Okay, COOH and COOH. So this is phthalic acid. When phthalic acid is heated in the presence of ammonia, then what happens? Water molecule get released and phthalic acid converted into the phthalimide. Okay, phthalimide, amide. Okay, what is happening here? When acid react with the ammonia, then what happens? It form amide. The same reaction is going to be here. Okay, so concentrate here. Same reaction is going to be take place here. Now we are writing here. What we are writing here? Ammonia in the presence of heat. Or we can say that we are heating phthalic acid in the presence of ammonia. This is a sign of heat, and writing the name of this acid. This acid is phthalic acid. Okay. So when phthalic acid reacts with the ammonia, then it forms amide. So I am drawing the structure of amide. Okay. Here, this is phthalimide, amide. So maybe the pronunciation is same, but it is not same. This is phthalimide, NH2, or here also NH. Okay, we can see here. This is Ar group. This is CO. This is NH2. So ArCO NH2. ArCO NH2. This is ArCO NH2. We can write here also alkyl group. So ArCO NH2. Yeah, ArCO NH2. Both are amide. This group is amide group. Okay. So what is here? Phthalimide. I am writing the name of this. This is phthalimide. Amide. Okay. Let's see here. This is amide. Phthalimides. So how the reaction happened here? Let's see. Okay. How the reaction happened here? This is the OH and this is the OH. Two OH group. So if it accept one proton, means one hydrogen and one hydrogen here, so it will become H2O molecule. What? It will become H2O molecule. So I am writing like this. It is becoming H2O molecule. Then it will lift. So how much H2O molecule will release here? One H2O, one H2O, minus 2 H2O molecule will be released here. And how much H is required? 2 H is required. 1 H here and 1 H here. So from where we can get this? We can get this H from ammonia. Now I am elaborating the structure of ammonia. Let's see here. We can write ammonia like this. H2 like this. So this group is same. We are looking here. This same group is here also. So what happened to the H? H reacted with the OH group. H reacted with the OH group. So when two molecules of ammonia react with the phthalic acid, then it forms phthalimide. Okay, then it forms phthalimide. Two hydrogen from two ammonia group will react with the two OH group of the phthalic acid. So what? So this is phthalimide. When we hit further, what will happen? We hit these molecules further. Okay. So what will happen? Let's see here. This NH2, suppose that this NH2, here is 2H. One H when goes from here to here, it will become NH3. What? It will become NH3. So NH2 plus one H from this NH2. So what it will become? It will become NH3. So NH3. NH3 ammonia gas will be released. So I am writing here the minus NH3. NH3 will be evaporate. Okay. And what is left behind? One N and one H from here. So now the structure will be what? So now see from here. Okay. See from here. Now the structure will be like this. Like this. This COO and this single N or one H is left behind. So I am writing here NH. So now this H becomes very acidic. The next reaction will depend upon the acidic nature of hydrogens. How it will depend and why it is acidic. The question is why it is acidic. When hydrogen will release from here, then what will happen? The N minus will be formed. When hydrogen will suppose I am just releasing hydrogen, so minus will be formed here, and this minus charge is resonance stabilized. Okay, so because of this resonance stabilized parts, this hydrogen become more and more acidic. So if this is acidic, then it can show the acid base reactions. So when we take some base in this solution, or when we put some base in the solution, what will happen? This H will be abstracted by the OH group or the basic group. So reaction will be proceed further. Okay. So I am putting some base. I am putting KOH. KOH is potassium hydroxide. This is a very good base or light base. So it is like this plus this minus. What will happen? This OH group will capture this hydrogen and K plus group will be attached to N. Okay. So now what will form? What will form? I am drawing this structure here. It will form like this. This C double bond O. Alright, same thing, C double bond O and N, NK, N minus and K plus or OH or H minus H2O. We can write this H2O molecular release. So we can write here minus H2O. Okay. So this is the phthalimide. This is the phthalimide or this is salt of phthalimide. So I am writing the name here also. This is phthalimide and this is phthalimide. I am writing now name here. Phthalimide. Phthalimide. Okay. This is the main reagent for the preparation of method. So this is this known as the Gabriel phthalimide synthesis. This is phthalimide. What will happen? This is minus, so it will act as a nucleophile. It will act as a nucleophile and it can show the nucleophilic substitution reactions. So how it will show the nucleophilic substitution reactions? I am putting something here. I am putting alkyl halide here. Then what will happen? See the reaction. I am putting RX. Okay. So I think I should show a longer bond. Okay. In order to make more clear. So I am making like this RX. So this nucleophile will attack from the back side. When it will attack from the back side, what will happen? This bond will grow. Okay. So what will happen? When nucleophile attack from the back side, this bond will break and X will be released here. Then what will happen? X and K form Kx, and A R group attached to the N. So I am writing the final structure here, isn't it? I am writing the final structure here. The structure is like this. This CONR CO like this, and minus kx you can write. Now this chemical compound is present in the basic solution, so we can say that when we do the basic hydrolysis of this, what will happen? So we are going to do basic hydrolysis. We are going to do basic hydrolysis. In hydrolysis, what we use? We use HOH, OH minus and H plus. So what will happen? This OH will be attacked here, and this bond will be shipped here, and it will become minus. When minus come back here, then this bond will be break. Okay, and this H positive part will be attached to this N, and OH, we have seen OH is going to C part, C double bond O part, and H is going to this part. Similarly, when this bond will break down, what will happen? One molecule OH will attack here, this bond will be shipped here, minus will come here, then minus will go back, then this bond will break, and this H positive will be attached here. Okay, so what we have seen here, this is NRH2. What is NRH2? I am writing here NRH2. RNH2. This is 1 degree amine. This is 1 degree amine. Okay, this is 1 degree amine. We have prepared 1 degree amine. 1 degree amine. And what is the side product? The side product is this. Side product is this. Salt of phthalic acid, CO minus, and K will be come from the KOH group, and it will become like this. O CO minus, OH and OH. Okay, this one stay here, and again K plus and K plus. Okay, so this is salt of phthalic acid. So phthalic acid salt is formed here, and 1 degree amine is produced here. So very important step in this reaction is that the nucleophilic attack. Okay, this part means what type of alkyl halides should be for these reactions and what type should not be. So this part I am going to discuss elaborately what type of the RX should be. Okay, so coming to the next page, here we are making a nucleophile which will attack on RX. So this is nucleophile. This is nucleophile which is going to attack on RX. This is R or X. When it will attack from back side, this X will be released. So if this R is chiral, then inversion is possible because it is SN2 mechanism. So if R is chiral, so I am writing some bullet point. Okay, if R is chiral, okay, and second and third I am putting some points. So first, if R is chiral, then क्या होगा? Then it can be for inverted product, means inversion is possible, means inversion. SN2 mechanism is this. So R should not be 3 degree, it should be 1 degree or 2 degree. So R should be 1 degree and 2 degree, not 3 degree, not 3 degree. So if क्या होगा? If R 3 degree, if R 3 degree, then what will form? SN2 is not possible because of the bulky group. So like this R and X. So this is very bulky portion. SN2 is not possible. Attack from the backside is not possible. So it will show other reaction, that is equi reaction, and it will form alkene. Okay. And fourth point is very important. That is halogen. Type of halogen. Halogen should be chlorine, bromine, and iodine. Not fluorine. If fluorine is very small and high electronegativity, so the other type of the reactions, that reaction is even CB, through the even CB mechanisms, it form what? Alkene in case of fluorine. Otherwise, chlorine, bromine, iodine is good for this method. Fluorine is not good. Fluorine will follow even CB and it will form the alkene. Okay. And the next thing is this R should not be AR, means alkyl group should not be aryl group, means aryl halide should not be used in this preparation. So I think this is also a very important point. That is what should not be, means ARX is not allowed because due to the partial nature of this bond, it is very difficult to break down ARX bond. That's why it will not participate in the SN2 reaction. So it should not like this. Okay. So now this is very important bullet point that should you remember for solving the different type of questions related to the Gabriel phthalimide synthesis. Now I am going to discuss some very important type of the question that has been asked in the papers, and it can be asked in future also. So you have to be very focused here. Okay. So I am writing some different type of question, and I will give you a little bit second time to you to check it. Okay. Also try to solve it. The first type of question. I am writing like this. This is making bullet point. This is 1. This is 2 and 3 and 4 and 5. Okay. So I am writing first. Here. Send the color. Okay. CnH2 R2H. Okay. Here NH2 here R3 NH2 here R NH R. Now NH2 aniline, this is aniline. And I think I am removing one type 4, very important question. It can be very important, like 6 point, like this. This is the last part, okay? We will end this. This is benzene. Oh my god. I'm making a benzene. I will do like this. NS2. Oh, NS2. NS2. This is NR2 group. So the question is here: how many amine can be prepared by the Gabriel phthalimide synthesis? From first to sixth. Now we are going one by one. I will discuss one by one. So when we have to check is it can be formed by this method or not. So what I will do? I am telling you the very simple trick. Suppose that this amine is here and I want to find is it can be prepared by this method or not. What I will do? I will break the bond. I will break the bond between C and N. I will break the bond. I will breaking bond. Okay, what will find? I will find this is this part and this part. So this part is what? R2HC and it was like this. In case of alkyl halide, this is the alkyl part, this is the halide part. So let's see the degree of alkyl halide. So here we are looking and I have found what? I have found that R2CH is 2 degree. This is 2 degree halide. What? 2 degree halide. So we have already discussed if 1 degree, 2 degree alkyl halide is there, then amine can be prepared. So this type of amine can be prepared. This type of amine can be prepared. Okay. Okay. Suppose I want to check the second question. So break the bond and put the X at this position. Put the X. So I am putting X here. When I will put X here, then it will look like that. Look like. Oh, this is not. This is not. This is not pro. So now see this halide. First find the degree of halide. So degree of halide is what? Nothing. This carbon is attached to 2 carbons. So this is 2 degree halide. 2 degree halide. Okay, if it is 2 degree halide, then yes, this amine can also be prepared. Okay. Now I am coming here. Okay, I am coming here. Now I am breaking bond. So what will form here? It will form R3X. Find the degree of halide. This is 3 degree halide. This is 3 degree halide. 3 degree halide is not good for the SN2 reaction. Not good for the SN2 reaction. So this type of amine cannot be prepared by this method, but can be prepared by the other alternative methods. Okay. So no, this is not possible. I am coming here. First in the end, when we see 1, 2 questions, then 1, 2 and 3 questions. This is 1 degree amine, 1 degree amine, 1 degree amine. All is 1 degree amine, 1 degree amine. Because N is attached to the single carbon. N is also attached to the single carbon. N is attached to the single carbon. But here N is attached to the 2 car group, 2 R group. This is 2 degree amine. This is 2 degree amine. Think here. This N is attached to the 2 R group. So N become 2 degree. N become 2 degree. Means amine. This type of amine is 2 degree. 2 degree amine cannot be prepared by this method. Okay. So this is also not, or this cannot be prepared by this method. Now this is aniline. Aniline, so break the bond. Same phenomena. Break the bond. When you break the bond, attach X here and make the structure. So you make the structure X. What you will see? This is aryl halide. This is aryl halide, and due to the partial double bond character here, nucleophile cannot attack here, and it cannot leave the X group. Cannot leave the X group due to the partial nature. But this reaction can be happen if if NO2 group is present or electron withdrawing group other also present at the orphan para position. Here no any electron withdrawing group is present. That's why this reaction cannot be carried out. So amine, this type of amine cannot be produced by this process. But here NO2 is attached to the para position. This is electron withdrawing group. In this case, what will happen when we draw the resonating structure? Then what we see? Positive charge come here. Due to this, attack of nucleophile is become feasible here. Okay. So when we attack NU here or nucleophile here, then this type of the amine can be produced. So the first thing or final thing what we have to remember, if any electron withdrawing group attached to the aryl group or aryl halide, then that can participate in the SN2 reactions, and that type of the amine can be produced by the Gabriel phthalimide synthesis. If there is no any electron withdrawing group is present at aryl halide, that will not participate in the SN2 reactions or it will not form related amines, okay, or corresponding amine. So here see, in order to check this, it will form or not. First I will break this bond and I will attach X here, okay. So I am making the structure here. Let's see this. Say this. This is electron with one attached here. So nucleophilic attachment is possible, and this type of X we should have for the preparation of this type of amine. So yes, it will go, or it will show SN2 reactions. So the main concept is that any reactor, any alkyl halide or any aryl halide, the last statement, any alkyl halide or any aryl halide, when they show SN2 reactions, then the related amine can be prepared by this method. But one very important case, that is the bridgehead molecules is very important in these reactions. So we are going to discuss bridgehead molecules, okay? The last one. So what is bridgehead? This is bridgehead molecules. This is the carbon. If you are putting X here, okay? This is alkyl part, this is alkyl part, this is halide part. So this is alkyl halide. So due to I think according to the previous discussion, we can say that alkyl halide participate in the Gabriel phthalimide synthesis. But this alkyl halide, the first point is we have to find, is it possible or it can participate in SN2 reaction or not. If it is participating in the SN2 reactions, then we can get the corresponding amines by this method. So here, attack of nucleophile become very difficult due to this type of the structure. So SN2 reaction does not happen. If SN2 will not happen here, then the corresponding amine cannot be also prepared. So this is alkyl halide. Even in case of some alkyl halide, we cannot prepare the corresponding amine by this method. So this important point are there. You have to remember this. After watching this, I think I have covered very important part of this reaction. I think the all part of this reaction except that. So if you see this, then you will be able to solve each and every question related to you. It can be comes in the NEET board or the maths or the year maths. You can solve any type of question. Now your duty is to prepare the question related to this topic. So we will meet in the next video.